This is the first in a series of videos that explain where all of the elements come from. So let's start by talking about the Big Bang. The universe started a little under 14 billion years ago, and it started with a bang. So basically, the universe started from nothing. That includes space as well as stuff. And then all of the space and all the stuff came out of just nothing and expanded. And I'm going to get into what happens along the way. But basically, what we have is that you start off with nothing, and then there's lots of energy, and the energy is causing space to expand, and it's expanding out. And at some point, we start to get particles condensing. That is, instead of being light and different energies of light, we have different particles like electrons, and then later we get some protons and neutrons, and then they start to stick together until eventually we have some elements. And in this series of videos, we'll be talking about how we get from those basic few particles of protons and neutrons and electrons to all of the elements that we know. Before we can do that, we need to talk about what an element is. So an element is the smallest unit of something that still contains a chemical identity. So what we have is a nucleus that's got protons and neutrons, and it's surrounded by electrons. A neutral atom has the same number of protons as electrons, but an atom can lose its electrons and still be the same element, and so we don't use the electrons to define what the element is. Neutrons just add mass. So the protons are what we use to define what an element is. The number of protons defines the element. So here what I've got is an element that has just a proton in the middle. And with just a proton in the middle, it is element number 1, it is hydrogen. This one has 2 protons and 2 neutrons, but it's the 2 protons that make it element number 2, helium. And so we define all our elements in this way. Now, there's another thing that we need to think about, which is a thing called isotopes. So I said that hydrogen is when we have just 1 proton. Now here I've got 1 proton. Here I've still got 1 proton, but it's got a neutron with it. Here I've got 1 proton and 2 neutrons. These are all elements hydrogen, but they are different isotopes. So they're all hydrogen, but they have different masses. And so we have regular hydrogen here described as protium. We have heavy hydrogen, which is deuterium, and really heavy hydrogen, which is tritium. Now, tritium is not stable. You can see here it's got a half-life of about 12 years. We can make it, and it's also made in space. But both normal hydrogen and deuterium, the heavy hydrogen, are both stable, although most of the hydrogen in the universe, and you can see here it's 99.985%, is just protons. But it's not just hydrogen that comes in different isotopes. Here you can see an example of oxygen isotopes. So here I've got the most common form of oxygen, which has 8 protons and 8 neutrons. Here we still have 8 protons, so it's still oxygen, but it has a couple of extra neutrons that add mass. Again, oxygen 16, that is the mass, it's the protons plus the neutrons, is the most common. Oxygen 18 is much less common, and all elements come in different flavors with different numbers of neutrons in them. Here we have titanium. So titanium is element number 22, and it has an average mass of a little under 48, but it has several stable isotopes. Here we can see the ones in color here are isotopes 46, 47, 48, 49, and 50. Since it's 22, that means this one must have 24 neutrons, 25 neutrons, 26, 27, and 28. We can see that titanium 48 is the most common one, but there's still a fair amount of the others. Now you'll see here, we've got the actual atomic masses. You'll see the mass is very slightly less than just 46, 47, or 48. We'll come back to that in a later video. Here you can see there's lots of other isotopes. These two are somewhat stable. That is to say, titanium 45 has a stability less than a year, but still more than an hour. And this one has a stability of more than a year. The others can exist, but they're not stable at all. And so this gives you the idea that, there are lots of different elements, and they all come with different amounts of neutrons in them that gives us isotopes. Okay, let's get back to the Big Bang. So remember, it started with a bang. And after about 3 minutes, we've made electrons and protons and neutrons, and some of those protons and neutrons have stuck together. So protons would be hydrogen. If you stuck one neutron in, you've got deuterium. If you stuck two neutrons in, you've got tritium. If you've stuck two protons together and you've got a neutron, you've got helium-3, and so on. Lithium is the third element. That's where you've got 3 protons, and it'll have some neutrons as well. And so 3 minutes in, still most of the universe is hydrogen. What this is showing you is what happens over the course of the first 3 minutes. So we've got lots of hydrogen, because that's just protons, and some of the hydrogen disappears, but still most of it is hydrogen. Most of the neutrons get sucked into other elements. So you can see most of them get pulled into helium, some deuterium, some tritium. You can see we also make just a little bit of lithium, beryllium. And so you can see here how in those first 3 minutes, we're able to make new elements. And after 3 minutes, we're not really making any new elements anymore. It just gets to being, this is what we've got. 3 minutes into the universe, and we've still got 75% by mass hydrogen and a little bit of these other things, but that's basically it. Now this begs the question, if we're going to talk about the origin of the elements that make up life, what is the human body made of? And what is our planet made of? Well, let's answer that question. The human body, by mass, is actually mostly oxygen. It's oxygen, carbon, nitrogen, and hydrogen, and a little bit of everything else. We have all the elements in us, but it's mostly these ones listed here. If we want to talk about the planet Earth, it is 32% iron, 30% oxygen, 15% silicon, 14% magnesium, and again, a little bit of everything else. But most of what we're seeing here, in fact, everything but hydrogen, did not exist at the beginning of the universe. And even 3 minutes into the universe, we didn't have any of these heavy elements. And so we've got to figure out where they came from. So where did all of these elements come from? Turns out that everything is made either during the Big Bang, in interstellar space, or as the result of stars dying. In this case, in 3 of these cases, the stars are completely destroyed. And this is what we're going to get into over the course of several videos. Now, just to give you an idea of where different elements come from, this is a really nice periodic table that shows you where all the elements come from. So you can see here, hydrogen is nearly all from the Big Bang. We've got helium is mostly from the Big Bang, and lithium we've got a little bit. We've then got some lithium and then beryllium and boron, which are the next elements made by what's called cosmic ray fission. We'll get into that in a future video. But actually, most of the lithium comes from low mass stars as they die, along with most of the carbon and most of the nitrogen. These are stars like the sun. They do not explode as supernovae. They die slowly over a few 100,000 or a million years, and they throw out elements that they've made over the course of their lives. They also make heavier elements, not just lithium, carbon, nitrogen, but also we can see here the yellow strontium, yttrium, zirconium, niobium, molybdenum, and so on. And you can see even everything up to lead can be made inside of these lower mass stars that do not explode. Low mass stars that explode are these exploding white dwarf stars, and they also make some heavy elements, but they're different ones than we see here. And in fact, this is where most of the iron comes from. We'll get into that. You can see that exploding massive stars, and this is what people usually think of when they think of where elements come from, and that's where most of the oxygen, fluorine, all of these things in green here come from. But actually, the heaviest elements do not come from those types of stellar deaths. And then finally, in one of our most recent discoveries, is how neutron stars in pairs merge together, and they will generate a whole bunch of elements. And you can see here, they're responsible for a lot of these heavy elements. And once you get past lead, that's basically where it all comes from. So we'll be discussing all of the ways in which new elements get made and why it has to be made the way it is as we go through this series of videos.